All right, so then there's firewalls. Oh, let me encourage this thing to go away. All right, so the simplest firewall is a packet filter that looks only at the header. So it looks at whether the packet is coming in or out and things like the port number. That's a stateless firewall. This is a pretty weak form of filtering. Stateful firewalls are better. It looks at the state table, so it knows if a connection is established or not, and typically only lets connections through if they're established. So it remembers it makes a decision based not only on the current packet, but on the previous packets and whether there's been a session established. Proxy firewalls hide the origin of a connection, so the external server sees only the address of the firewall, like a VPN. And application layer firewalls are what everybody has now in the world of Palo Alto, where the firewall does what they call deep packet inspection, which everyone freaked out a few years ago, and now they're all used to it, where it looks at the whole packet, and so it can do things like, for example, block BitTorrent. And if you move it to another port, it still blocks it because it looks at the structure of the entire packet to recognize things, and everybody's using this now because they want to control things like Dropbox and BitTorrent and Facebook, and you got to have a layer 7 firewall that looks at the complete packet and has complicated heuristics to do that. There's circuit level proxies like SOX proxies, which were the original way to move traffic out of networks. And the Tor is a SOX proxy. You can make various kinds of VPNs this way, where it encapsulates traffic at a high level so it can move any kind of traffic. They used to have this thing called a Bastion Host, was your gateway to the internet, and it was supposed to be a limited secure server that would be the first point of contact, hopefully, so people couldn't hack it. It was dual home with 2 IP addresses, so one going internal and one going external. This was the previous screened host. These are the early things that have pretty much been replaced by enterprise level firewalls these days, but all the various devices that sat between your LAN and the internet and made some attempt to create a security boundary. Now most people use DMZs, or the even much more complicated multi-VLAN networks with many different layers of security. But the idea is you have one firewall on the outside to stop junk that nobody wants. You have a semi-trusted network with publicly exposed services like your email and web server, and then you have a private network where nobody can get in until they prove they're actually an employee by going through a VPN concentrator or something. And that way you have layers of security and different levels of security in your network. You can do it with one firewall in principle, but I say most people have more layers than this now in their network. So a modem connects you to something like a phone line. So it takes the digital traffic and converts it into a different form of traffic that can move out through the connection point. The DTEs and DCEs are where you connect from network protocols to the phone network. And the CSU, DSU is another signal device used to connect for these connections. And so for secure communications, you need authentication protocols. The original one was PAP. This sent passwords unencrypted over the wire for things like Telnet and FTP. This is, of course, not a good idea, but it was the first way to do it when nobody thought about sniffing and networks were not shared. Then they upgraded to CHAP. CHAP would send you a challenge. You would add that to your password and hash it, and then send the hash over the wire. So the thing you sent over the wire was not exactly equal to your password. But of course, the early versions used old hashing protocols like MD5, and they were not very secure. 8021X is the extensible protocol that can provide security at many different ways. It can be as simple as just MAC address filtering, or as complicated as certificates that are really quite secure. So you connect to the network. You are now a supplicant. You are trying to join the network. You then talk to an authentication server who collects some kind of credentials from you and decides whether you're authorized, and then they let you in the real network after you've proven that you deserve to be there. So EAPOL is EAP over a LAN, Extensible Authentication Protocol. That's one way to do it. You go to an authenticator. It goes to a Radius server, which has the repository of credentials, and then it decides whether to put you on the trusted network after deciding if your credentials are matching the credentials stored on the Radius server. So EAP MD5 is one of the old vulnerable ones. LEAP was Cisco's proprietary attempt to fix WEP by making a lightweight EAP. It turned out to be better than WEP, but still unsafe and not recommended anymore. EAP Fast is a Cisco replacement of Leap that is considered more secure. And EAP TLS uses transport layer security, and so it's really quite secure if you're using a modern version of TLS, just like HTTPS. And of course, it means that you have to have digital certificates, which has been considered costly, although now certificates are in principle free. And so maybe that we should not talk so much about it as being costly. EAP TTLS is another technique. Yeah. Yeah, sure.
EAP uses PKI, or PKI is very both client and server-side certificates.
This EAP TLS uses certificates on both ends, client and server, which was considered prohibitively expensive until we now can get free certificates. And I don't know anybody using it yet, but now the cost barrier should be gone. Yeah. And this is the more common one where you put a certificate only on the server and not on the client, like the internet. And this one is therefore relatively cheap to deploy and very common, and still considered quite good. Then there's PEEP. Protected EAP is another one that's similar to the one we've already seen. And there's some cahoots about these things. Number 5, right at the bottom. Okay. Okay, I think 5 is the number. I think so. All right. Okay, which firewall uses only header information? That's a packet filter, the first generation of firewalls. Which device operates at OSI layer 3? SOX is at 3? No, 5. Oh, thank you, 5. Okay, now I feel better. I was baffled. Layer 5 is SOX proxy. Okay, good. All right, which system gives you port-based network access control? AO2X, that is port security, which in its simplest form just uses the MAC address, and we were talking about it earlier. If you randomize the MAC addresses, this is going to be more difficult to do. Which system is vulnerable and should be avoided? Leap. That's considered broken. Joshua Wright wrote a tool called Asleep that hacks into Leap. My students do it in a hacking class, and Cisco got very, very, very angry and condemned him and said, this rotten bum ruined millions of dollars of infrastructure, which is what people, they didn't say we sold people junk. They said it was perfectly fine until someone told them it was junk, and we needed to get rid of this rotten guy telling them that, and everything will be fine again. This is what all authority figures always do. Just shoot the messenger, bury the body under the rug, and then go on as before. Anyway. So Robert T and PC are the winners. And we're still in chapter 4. Robert T and PC. Okay. So VPNs, we've talked about many times. The idea here is to make a secure link over the internet that would give you the security we used to have back in the days of before packet switching, when you'd have a single piece of wire connecting you to the other end and nobody else using that wire. That's the goal. So you're a private network. You create a virtual network with authentication and encryption. So SLIP was the first way to do this. No confidentiality, integrity, or authentication. It was just a way to connect point to point. There's point-to-point protocol came out after it, which again adds some of these things to it: confidentiality, integrity, and authentication. PPTP was the early, extremely popular tunneling protocol. I think it's the one that's still by default available in all versions of Windows. It uses TCP 1723. It is old and unsafe. As students, I also give them homework hacking into this. It's, all old encryption schemes have pretty much been broken. You have to keep updating to the newer ones. L2TP was Cisco's proprietary tunneling protocol, but it was not encrypted. It was just a way to move packets over a different kind of network, so it would encapsulate them and transport them, but it did not provide confidentiality. IPsec is the new hotness for VPNs, backported from IP version 6, considered very secure. It is also very complicated with a lot of different parts and modes, but an L2TP/IPsec network is considered one of the most secure possible VPNs these days. So you can run it from host to gateway, where your client is connecting. You can also if you make it host to gateway, then you have to put a VPN client on all of the laptops in your company. That's one way to do it. Another way to do it is to use it to connect 2 branch offices of your company, so your clients don't know they're on a VPN. Just a way to cheapen your internet connection, so you don't have to pay for like a dedicated T1 from one location to another. And you can also go from host to host. So here's tunnel and transport mode.
So just remind me,
yeah,
that the transport mode was the one that did not have some kind, no config.
That's what I'm trying to see. Yes, I think the transport mode leaves the original IP address on it and just encrypts the data. The tunnel mode hides it in another packet and puts another header on it. So yeah, and in practice, they worked real hard at making these 2 modes, and many people, and Bruce Sire and other people said, why even bother? Everyone will just use the most secure one. Why would you make a halfway secure one? He said, this is one of the many arguments about IPsec, is that it's far too complicated and has too many options. They should just, like, there's also a fast key establishment protocol, which is less safe. And he said, you should just remove about 90% of this protocol and leave you with just the secure version and get rid of the rest. Make it less complicated. Anyway, SSL and TLS, we know SSL was the original way of encrypting internet traffic that is now deprecated. TLS is the new hotness. Most people call it SSL, but it hasn't been SSL for years. It's really TLS. They're, of course, much easier to use. If you configure one of these, you can just connect to it with a browser, and you don't need to put a special client on your machine. So remote access, if you want to remotely access a server, there was a time when we had ISDN. The only point of this is you didn't have to interrupt your voice phone call to connect to a server. This gave you basic radio interface and primary radio interface. I think this is pretty much obsolete. DSL is really still around, quite hot, because it can be very fast. If you're close, you can get up to 50 megabits per second. There's various different versions of it. This is just a way of using a very intelligent modem to run very high-speed traffic over the same old analog copper wires by just exploiting them in more detail. Although it works a lot better if you have fiber optics or a digital communication medium. Cable modems move your cable traffic through the cable modem. Cable traffic can be used for broadcast TV, and that's pretty good. One technique is callback. This is a pretty good security procedure where you connect to your network and you request a connection and it doesn't connect you. Instead, it calls you back at your known good phone number to make sure you are really the employee. You have to have your phone number in the directory. This was pretty good back when people actually had to be in their home connecting to work. Now that everybody's on the road with a cell phone, this becomes a lot less useful. Caller ID is something people use to identify you, but this is a really bad idea because caller ID is not verified anywhere. It's like a from address in an email. You can put anything you want there. So it's frequently used by people like emergency services to tell who you are, but it is notoriously unreliable. RLogin and RSH are old Unix remote access systems that sent clear text like Telnet. The modern ones are VNC and RDP. VNC is the open source community. These are ways to move a graphic desktop to you from a remote server. So you can use the mouse and open windows and everything on a remote server.
Yeah. Quick question. So then probably this is just my knowledge that I don't know how we used it in one time. Why is the port at 5900? I know to 1023
Right.
is the
Yeah, 0 to 1023 were the well-known services. So in the early days of the internet, they were assigned to really fundamental things like Telnet. And then as the internet grew and you had more protocols, people chose other numbers. And the idea was the numbers between 1024 and 49152 would be used for this, other services that are not as fundamental, but they're popular.
Right.
And the temporary throwaway ones would be above 49,000. That was the plan. So these other numbers like 4,900 and 3,389 are available for anybody to use. But if somebody puts something up there and it becomes popular, then people get used to it always being for that. But it's not officially reserved. That's all. But you could make something else and run it on this port. And, you know, I don't even think it'd really be a violation of any RFCs or anything. It would just be an unwise decision because sooner or later somebody at your company would want to use this popular thing, and then it'd be irritating to have something else on the same port. There's a similar collision in acronyms. I remember, and file extensions. I thought it was hilarious. I took a Microsoft certification class, and they talked about a protocol for like a security file that you would make that was used to transmit security settings from one domain controller to another, and they used an extension of PDF, and we're like nobody's already using that extension. Because Microsoft used to have a policy that no other company exists, and you will never refer to any other company's product. And Microsoft first had their map come out. If you went to look at Apple headquarters, it was flat, just being a vacant lot, because you could. Their original policy was, we are the whole world. You will only push the Microsoft version of everything. You will never admit that anything else exists in any Microsoft document. That was part of what got them sued for antitrust. So they would just walk right over anything casually because no other company is significant. They had to knock that off after the antitrust lawsuit. That put the fear of God in them, and they knocked off this rapacious stuff. Anyway, so GoToMyPC and LogMeIn are common consumer-grade things where you put this on your machine and it runs a client. And the cool thing about them is that they connect to a web server and then connect to your machine from there, so you don't need to open goofy ports in your firewall or anything. Another one is TeamViewer. Is another commonly used one. So there's virtual desktop infrastructure, is where you put the server has your whole local computer running as a virtual machine, and it just lets you see the desktop through an IDP connection. That's what we were talking about before, the thin client, where you don't really have a full PC. You just have sort of a viewer onto the server. And then you can have application virtualization, where you don't have 1,000 copies of Microsoft Office. You just have one running on the server, and everybody's sharing that one. And this can be a good idea for security and even for performance and updates and everything if you do it right. Then there's screen scraping, is the process that VNC uses to capture the data on the screen, packetize it, and send it to you. RDP uses some different system, but it has to accomplish the same thing. It has to make images of the desktop and a whole series of them and send them to you somehow so it can draw the desktop. Instant messaging is real-time chat, of course. This started with IRC, which was originally for two people using the same Unix server at the same company, and then they had public services that would port the IRC from one channel to another, and then it spread onto the internet with all these other ones for real-time text-based chat. And now people have added audio and video, so you have AOL Instant Messenger and ICQ and Facebook Instant Messenger and all that jazz. These things are notoriously insecure. They had buffer overflows, simple exploits to take over machines, people impersonate people, people hack them through there. They're pretty messy. They were really popular a while ago. I don't hear that much about them anymore. Now I mostly hear about like Skype and FaceTime are the ones I hear people using. And some people tell me Skype is kind of old and there's something new and better, but I'm not sure what it is. Zoom is my favorite, of course, as you can see. Zoom seems to be the best for teachers. This horrible thing called Cisco Net Meeting or Web Meeting WebEx is just awful. Every time you use it, like 20% of the people can't get to it because it uses some goofy port or something. I can't teach a class over it. I don't know how to have a meeting over it. I don't know how to even exist. Zoom is so much better. If you have Zoom, everybody can see the stuff. When I tried to use WebEx, we spent much class time arguing about why can't you see it and helping you. In fact, I had two students who were lab assistants, and they actually would connect to the class, and then they would have a second protocol running to connect to one student, so that the student had these weird kludged together things so they could see it. And then we finally found Zoom, and it was so much better. Yeah.
Share like a screen and all that was just horrible.
Yeah.
break down.
Yeah, so I think this is another market where the old standard failed to innovate and somebody came in and disrupted it, like taxi cabs and the USPS. Cisco didn't stay with it. Anyway, all right, so PDAs are these personal digital assistants. Before there were smartphones, I don't know if anybody even uses these things anymore. Yeah, I know, that's ridiculous. There used to be these, I think these things went the way of the dodo bird long ago. Of course, they had the same problem as smartphones. You have all this company data on this little gadget, you're going to lose it, and the network connection isn't going to be secure and everything. So there's a wireless application protocol intended to deliver services that uses wireless transit short layer security. And there's WAP, is a browser that connects to a WAP gateway and lets you see wireless pages. I'm not quite sure if this is used on smartphones anymore. No, it's been gone, I think. All right. The content delivery networks are a real big deal. Cloudflare is the one I know best. Another big one is Akamai. If you have a website and people view it, they're all coming all the way to your web server. But once you get big and people in other countries are trying to see your website, they don't really want to wait for the traffic to come all the way from another country to you, and you don't want to pay for the bandwidth of it all. So what you pay is for reverse proxies to make a copy of your website everywhere and just serve it from a local copy. And this means you don't have to pay for all the bandwidth, and the customer gets a better experience because they're really seeing your page loaded locally. So the proxy server company has to have a big global network, and I know Cloudflare and Akamai do, and there are others. This led to an entertaining mess in the days of Windows Server 2012, I think, because Microsoft was accused, I think it was 2008. You went to the Microsoft website, and then you ran a tool like Nmap, you would find that it was being served from a Linux server. And people went crazy, humiliating Microsoft for that. And Microsoft had a whole campaign of dog fooding, living on your own dog food, and making sure that all their products are running on Microsoft services. And it was never really on a Linux server. What happened is they paid for Akamai as a content delivery network, and that was Linux. So Microsoft thought they were serving their stuff from Microsoft servers, but the actual end users were getting a copy from a Linux server. And, you know, this is like the other scandal, which I'm amazed never hit the time, which is iCloud is in Azure. I find that hilarious, and I think it would embarrass the hell out of Apple if they had to admit. I went to Microsoft search. I was taking the test and I was waiting in the waiting room. I asked the guy, "What are you doing?" "Oh, I'm here getting my Apple cert." And I said, "There are Apple certs?" And he said, "Yeah, there are Apple certs." I said, "What kind of cert?" "An Apple server cert." I said, "There are Apple servers?" And he said, "Yeah, there are Apple servers." And I said, "I've never heard of an Apple server." "They're Apple servers. They're important." I said, "Do they work with domain controllers?" "Yeah, they do. They're going to be fine." He had to take his Apple cert, and you know, Apple can't run servers worth a damn. They never have. They tried a few times. They just give up and go in the corner and cry. They haven't got that skill. They're good for the end user, but servers, they got no clue. Anyway, all right. So we got some more cahoots, and I think that's the end of this section. So. All right. Okay, which one gives you transport but no encryption? L2TP is just a tunnel, but it is not a secure tunnel. Which one is old and unsafe? PPTP, the simplest protocol to set up. It's been broken long ago, so it's not considered good, but it is so easy to set up. Every Windows machine has it built in by default, so you can very easily set up a PPTP tunnel, but you should be aware it's not very secure. It's probably better than no encryption at all, like WEP, but it's not very good. Which one runs over 3389? RDP, by the way, there's another RDP 0-day out there. And the RDP is notoriously insecure, and there's another huge attack spreading through RDP servers. There's been a bunch of them. My college just blocks it entirely by default. Everyone's got pretty fed up with it. You'd be a lot better off to use one of the third-party things, like TeamViewer or something. RDP, like Microsoft's file sharing, SMB, both of them just have an endless chain of serious flaws. Anyway, which IAM system has been around since the 80s. Okay, that's IRC, Internet Relay Chat. All right, so Coast, Jane, and PC. I think Coast is new. They may be the person connecting over the internet. And Jane and PC. Okay. Do I have someone connecting over the internet? I do not. Coast must be one of you then, all right? Anyway, so I think that's it for chapter 4. Let's take a look at chapter 5. All right. So this is identity and access management. All right, so we'll talk about authentication methods, ways to make sure you know who someone is. So the simplest and cheapest and most common is something you know, a password. It is not the best by any means, but it is the cheapest to implement, so it's the most common. Something you have, like a card you carry around, or something you are, like a fingerprint. And there's a fourth type, which is location. But the first three are the main ones, and therefore you have passwords. You can have static passwords, is the most common type. Passphrases are much better, where you have a whole long sentence with punctuation. There are one-time passwords that you use only once, and you have something like a gadget that keeps pumping them out. And there are dynamic passwords, which are generated on the fly for a certain purpose. So static passwords are reusable, may or may not expired. Typically, users make them up. This is the main authentication procedure in the world, and it is notoriously dangerous, and people hack them all the time, and people choose stupid passwords, and there are huge lists of hacked passwords out there, and we're all pretty fed up with passwords. They're very annoying to use. Everybody can't remember enough of them, and the best thing you can do is have a password manager. So you can use, the most important thing you can do is to use a different password for every service. Most people use the same password everywhere, and this is just madness. I did that until I started going through data breaches, and I became aware of how much they are just throwing your password on the ground at the other end. So that's the problem. Somebody will get hacked like Yahoo, and they'll have your Yahoo password. If you use the same password everywhere, now they've got it. So you really need a different password for every service, and you can't possibly remember them, so you need a password manager. So I got one finally. I got, I think, LastPass. There's a bunch of them. Get one and get used to it. And probably don't use your browser for the password manager. That's not a good idea, because those are too easily hacked. I know Chrome, I quit using Chrome when they started synchronizing everything and trying to trick me into synchronizing when I didn't want to. Somebody got hacked the other day. They hacked, once they get control of one machine, they get control of your Chrome. Then they get all the stored passwords in Chrome. Now they control your devices. Now they're in your bank and everything. I think a browser-based password manager is probably an unwise decision. I would use LastPass or something like that. There's a bunch of them. I used to use RoboForm for a while. That was nice. But anyway, you got to have some way of keeping track of them all.
Password manager, sorry.
Yeah.
I know you probably have encrypted it, I heard.
No, well, they're all encrypted. So I use this one here, which is, I think, LastPass. Sure, they did. And they passed it. Actually, I kind of prefer using companies that have been hacked, because now they had to upgrade. My attitude is the ones that haven't been hacked don't know they're hacked yet. But anyway, LastPass, so you store passwords, and it all is behind a master password. So they're encrypted, and they're in the cloud, so you can put it on another device and stuff. So it's pretty good.
I still can't trust it.
Well, that's a problem, trusting it, yes. Now, if you don't want to trust anybody, then you should write them down and keep the piece of paper where you keep your $100 bills. And that's not a bad idea. We already know how to secure paper.
Well,
So that's for non-technical people. I tell them that. Just write them down.
I don't carry it with me.
Well, that's the other. See, that's the other problem. If you don't carry it with you, then you can't log in from other devices, which is not a bad policy anyway. One thing I did, I used to log in from student machines, and then I realized this is really dangerous. And so I finally, they made good enough laptops I could have a good laptop. Now I just do everything from my own machine. That's a lot safer, of course. Yeah.
But yeah, I don't carry it around. And
yeah.
the old adage, I think, I love my mom. Is it that? Do you need it that quickly? If it is, then you know what? You should carry it. Otherwise, live with it.
That's true. That's true. And basically, it's true of all security. In order to be more secure, you have to put up with less convenience. So you have to find your own balance of convenience and security.
LastPass expensive?
I think it's free. I think I'm using the free version. I think just like Kahoot, I think there's some features I don't get, but I get enough features. I don't think I'm paying anything. RoboForm costs something, but I think LastPass is free. Yeah. And there's a bunch of others. And as far as I know, they're all about the same in quality. The main giant leap is using one, because if you don't use one, you pretty much have to use the same password everywhere. And that is really bad. Anything to get away from that is a big step forward. Yeah. So long passphrases are just long sentences with punctuation and everything. This is a good idea, especially as long as you don't choose well-known phrases like song lyrics or something. One-time passwords, you can only use once. This is typically what happens when you do a password reset. Let's use this password once or something, but there you have a now password distribution problem. They somehow have to send you that password, and that's a problem. Dynamic passwords change automatically. So you carry a token like this that changes every few seconds, and you type it in. Yeah, these RSA things were considered the gold standard of security, and then RSA got hacked by the Chinese.
So and that first, and then you still have to type another string of numbers.
That's right. But what happened is RSA got hacked by the Chinese, and then the Chinese hacked Lockheed Martin with the data they stole from here, and Lockheed Martin announced that the attack had failed. But if you understand how it works, you know they have to say that even if it succeeded. And RSA said, we will not say what the Chinese got off our servers, but just coincidentally, if any of our customers would like free replacements of all the hardware, we'll do that, but only if you sign a non-disclosure agreement. So they will never admit what happened, but it must have been god-awful. So what it means is they must have had a master secret that could predict them all. And I'm surprised, because Google Authenticator is open source, because they don't have a master key. You can install it on your server, you can cross it out to your end devices, and then you start it with like a seed that you determine, and nobody else knows it. I thought these were the same way, but apparently it's all going back to them, and they have the master key, and the Chinese stole it, and now they can predict the numbers. That's what it sure looks like. Well, I didn't know it either, but at this event, I mean, I said, when they hacked RSA, I said, so what? They won't have a master secret. It doesn't matter if you hack RSA. If I buy one of these, I'll just have my own password. But apparently, it did matter. And the only reason I can think of is then they can make you pay a license fee, and they can turn it off from the central server. That's right. Right. My first thought is, logically, mathematically, you wouldn't need to have a backdoor in this system. And of course, you wouldn't put one in, but apparently they did. Yep. And to be fair, they're probably not just to hide their own dirty secrets. The fact is, since their customers are military and major financial institutions, probably their customers would also demand that they never explain what happened. They probably never, both the RSA and their customers probably have strong reasons to never admit what really happened here. But it is kind of annoying to people who would like to understand security. We really don't know what happened. All we have is like cover stories. So God only knows what really happened behind the scenes. I do know things like this happen. I read an article several years ago, which is impossible to verify, but it sounds all too plausible. They brought ATM cards out in Britain about 15 years ago, and people were very reluctant to use them. They felt like unsafe using some machine. They wanted to go to a teller and talk to a human, which they trusted. So to encourage adoption, they pushed it out, and government gave subsidies to people and put ATM machines everywhere. And it turns out that the person that designed the ATM cards made them so they assigned a pin to you, a 4-digit pin, but he made it so there were only 3 different pins. And you had 3 tries, so he could get in anybody's account. And after that, he started stealing money. And they hired a security engineer to analyze this. And he tested it, and he found this. And he told them what was happening, and they made a decision to just let it go on and accept that amount of theft in order to avoid shaking public trust in the system, and wait for those cards to expire and replace them with better cards. And nobody ever found out. And then they refused to pay the security consultant's contract, and he couldn't say anything because he signed an NDA. And it wasn't until 15 years later when that expired that he could finally come up with the story. And I don't know if that's true, but it certainly could be true. And it could very well be that these things were never safe, and they were just keeping it secret, the back door. And, you know, it's, anyway, that's why Bruce Schneier said, in an ultimate sense, security to obscurity is all you ever have. There's always a key hidden under the mat that you hope they don't find. And all these other systems have just found a better way to hide the key. But fundamentally, that's all there ever is. There's a secret somewhere, and if they find it, you're hosed. Anyway. Yeah. So anyway, strong authentication. Any of these is multi-factor authentication. This is much better, where you have two different factors, and it can't be two of the same type. Something you know and something you have, or something you know and something you are, is good, because the idea is if someone steals the database, they don't have both of them. They have the passwords, but they don't also have the fingerprints or the smart cards. So now they can't exploit 1 million stolen passwords. They have to do a targeted attack against one person, and now they have to do a real physical theft of your property, which is much more expensive.
A question
Yeah.
I have. So you know how Apple, back then before the Face ID, they had the thumbprint.
Yeah.
Do they store that in the device, or is it in the cloud, or is it encrypted, or what?
It's a very good question.
Biometrics.
I know the biometrics are a huge issue. A lot of people push biometrics as the answer to everything. The huge problem with biometrics is you can't change them. If somebody gets your thumbprint, you can't do anything, and you're leaving it everywhere, on your glasses and the door and everything. So one guy was championing biometrics, and so they took his thumbprint and published it in a magazine, an advertisement, and said, "How smart are you now, wise guy?" I mean, so biometrics have come back and forth. Technically, what they say is they do not store your fingerprint. They don't store. All they do is they calculate some mathematical stuff, and they store that in a hashed form. So what they have does not make it possible for someone to steal your fingerprint. I don't know. That's what they say. A lot of people are worried about this, but they don't take a photograph of your thumbprint and store it in the cloud or anything. It's not that bad, at least according to what they say. The main thing, I have fingerprint authentication on this Mac, and I've had it for 6 months, and I've finally given up. It just never works. Every time I turn it on, I go tap, tap, tap like 6 times, and it gives up. After it's going, sometimes it recognized me once after 6 times, and I've canceled the registration and re-registered it many times. I don't know what the hell the problem is. I've just given up. I think my fingers are too big, or my skin is too dry or something. But for me, it's useless. I just type in my password every time now because I've gotten fed up with it. All it does is frustrate me. But anyway, but on my iPhone, the face identification does work very well. I very rarely have to type my PIN into my phone.
What does it do with the face? Do they take a picture of your face, or what
I don't know. That's a good question. I don't know how it's done it. I just know it works, but I don't know whether it's in the cloud or what it's doing.
You know that 24 Fitness takes your thumbprint to go get in.
Oh.
For the longest time, I told them, I don't want to give you.
Yeah, well, you know, several major airlines have now started using face identification to get on the plane, and you have no choice, and people are accepting it, where you don't have a boarding pass. They just have a photograph, and the camera spots you as you walk on. This is going to be the standard very soon, and many airports are already doing it. And they said you're afraid a lot of customers would protest, but that has not happened. But I can understand that. 90% of airline passengers are just harassed, and they say, yes, anything to make the line move faster and be less of a hassle. And the government has huge databases of all this stuff. I know American law enforcement for the last 20 years has had policies of taking DNA from everybody they arrest, even if they never charge them, and putting it in a national database. And they've got a ton of it. And, you know, there's the privacy advocates complain about this stuff, but they haven't held much of it back. And the license plate readers, holy crap. They record where every car is all the time, and it's stored in public databases that they just hand out that keep getting hacked. You know, years ago, they said America is the #2 most surveilled society in the world. The average American has your photograph taken 150 times a day. The only people that do it more is Britain. And Britain does it even more, and they have microphones hanging out in the street to record what you say. That's illegal in America. So, but you know, when they ask the average person in British, they say, I don't care at all. The government can snoop all they want because they have a lot of terrorism. Sarin gas, and people are afraid, and they very much want more law enforcement snooping to try to save them. We just don't have much terrorism over here. If we had some more terrorism, I think Americans would shut up about privacy too. But anyway, So you can just guess passwords. This is kind of funny. Most people can actually guess their friend's password by just thinking of what they would do. They probably use their favorite football team or their dog or something. All right. Yeah.
So what if you wear a mask? You have
Yeah.
a facial recognition and you wear a
Oh, yeah.
mask.
Oh, well, you know, they gave this to me at DEF CON. They have, you can wear a hat or a pin or a shirt with reflective material on it, and it'll foul it up. And you even makeup, it can even be, they've discovered, because they use AI is very screwy. There are things, making a small modification that a human doesn't have a problem with can totally screw it up. Like there was a diagram where they had people wearing things that put like colored squares on their face. And if you take like a picture of one person and put like 3 colored squares on it, the AI will recognize them as a totally different person because it doesn't use the features that we would use to identify you. It just practices until it makes up something it saw there. And so, in fact, there are privacy caps that just have a shiny thing on them, which will blur out the picture. There's a bunch of people doing this. You could wear something that will foul these up.
Because when we put on makeup,
Yeah.
there are ways to conceal
Oh, yeah.
a lot of the things, and I just wanted to know.
Yes.
Besides masks and everything.
Well, you know, what I think there'd be a market for would be to have makeup which blocks the camera but does not look bad to humans. And that would be entirely achievable, I think, because the camera uses infrared light and stuff. You could probably make makeup that would block the camera but not make you look ridiculous to normal people. And that would be you make money with that. That would be like the wallets with the tinfoil in them. There's a bunch of people nervous about privacy that would go for that. The prototypes I've seen in several papers have been kind of funny looking, like sticky stuff on your face or something.
A couple of banding your face, that would work too.
Yeah.
I wouldn't assume that. You'd have to test it. The AI is using different marks than you do, so just making you look weird to a human is not necessarily the right move. But if you can totally make yourself unrecognizable.
Right. So just the way the AI is written. Yeah. Thank you. That helps a lot in understanding.
Yeah. It is a big issue, and of course there will be all these forms of rebellion going out there. Anyway, so if you don't want people to guess passwords online by using a tool like Hydra that will try thousands of passwords, then you have to have an account lockout, where after a certain number of failed passwords, they get locked out for a period of time or until they go to talk to the administrator in person or something. This is a very important security measure. A lot of online systems don't have it, and that's ridiculous. I mean, you should not let anybody have an infinite number of guesses from one IP address. So if you, plain text passwords have not been stored on computers since the days of MS-DOS, except for Android phones, which Android doesn't, but the apps often do, which is insane. But anyway, what they do is they store password hashes. The password is scrambled in some way to make it hard to unscramble. The problem is most old hash routines are too weak and are easy to crack. You cannot reverse a hash, but you can crack it, which means you just try millions of passwords in a list and find a hash that matches. And so if you can calculate hashes fast enough, you can try a really big list. And the famous one is the RockU list that was like 100 million passwords. And you can use that against Windows hashes because you can easily calculate 1 million hashes per second on just a normal machine. Linux uses a much safer hashing routine where you can only do something like 100 hashes a second. And that makes an enormous difference. Now you can only try a list of maybe a few tens of thousands of passwords. So if your password is not just a common English word, you're fine. Whereas in Windows, your password has to be very exotic to not be easily cracked. So password hashes are stored in Etch Shadow on Unix systems. In Windows, they store them in the SAM file, part of the registry. And domain hashes are on the domain controller. Windows hashes are all pathetically weak and trivial to crack. Is a fundamental problem. In fact, you can crack Windows hashes by just Googling them because Microsoft adds no salt to them. So passwords ever since 1993, the first version of Windows NT, are still exactly the same today. So the internet has accumulated many, many lists of Windows password hashes, and you can crack any common password by just Googling it.
You have the USB, just plug in the USB and just reset any Windows password right now.
If you boot from the USB, maybe. Yeah, that's right. But the prevention from that is BitLocker. If you have BitLocker drive encryption, it won't work. But yeah, there are a lot of attacks. Anyway, so you can capture the hashes from network traffic. By the way, Windows did improve the algorithm for their network traffic hashes. Not for the local storage hashes, but the network hashes use this NTLM v2 hashing, which adds another layer of encryption on top and makes it somewhat harder to crack. You read them with various tools. The SAM file is also encrypted while the machine is turned off, but when it's running, the key is hidden in the operating system and people have found it, so they can decrypt the SysKey encryption. So here's password and password hash calculator, and notice the landman hash right here, E52, is equal to E52. 82 people with this. This is lowercase password, and this is capital password. The LM hash routine used by Microsoft in Windows XP and earlier operating systems was so ridiculous, it didn't distinguish the case of the password. The algorithm would change the password to all uppercase and then break it into two groups of only 7 characters and then hash them separately. So it was possible to just try all possible passwords in a reasonable amount of time. Amazingly bad. And because it was designed long, long ago for many older hardware that was really slow and weak and never improved. Microsoft is, for some reason, extremely slow to improve their password system. The current one they use was developed in 1993 and never updated. Yeah, hash calc, yeah. So a dictionary attack is the most common technique. You have a list of possible passwords and you try them all. So the typical countermeasures are password complexity and length rules, which are pretty ineffective, where you force them to mix uppercase and lowercase letters and stuff. What's much better, by the way, if you really want to protect yourself, is Australian Microsoft-oriented researcher called Troy Hunt has made Have I Been Pwned? Or Have I Been Pwned? And what he does is he collects all the dumps of stolen passwords. He has them all, and he has a database, and he has really grown this to a popular, this is really a huge thing. He's going to sell it to one of the major security companies. It's on the market now. This turned out to be enormously powerful. You can put in an email address, and it will tell you if your password is leaked, like mine. There. Yep. It'll tell you've been pwned on 11 breach sites and 1 paste. And, you know, people found some of my old passwords from old services. You can find out, and you even made an API, so you can put this in connection to your domain controller and your web service, where when a user types in a password, it sends it to his server and tells you if that password has been a leak, and it won't let users use it anymore. This is a really good idea. This is so much better than trying to use some pattern like you must have 1 number and 1 special character. This makes sure that your password has not been leaked by anybody. That is much better. Yeah. Yeah, this one just tells you if it doesn't reveal the password because they don't want to help you hack. But there's a way with the API to send passwords up, and it'll tell you if that password has been used. So, which a lot of people are very excited about, and a lot of people are building into commercial products and commercial industrial systems to use this system, and that's why it's grown so much that he wants to sell it to like Cisco or Microsoft or somebody and have them be the repository of this and the maintainer of this, because this has turned out to be an extremely useful service. So much better than password complexity rules and length rules. This accomplishes what you really want. Does a criminal have this word in their database? That's what you really want to know. Yeah. Yeah, and let's see if I think you can put passwords in here too. Let's see. Yeah. 7 billion accounts have used that password. So you can put passwords in here too. Yeah, it tells you how many times that email is in a dumped list of emails and passwords. Which means that many accounts logged in with that email have been breached, which is like the LinkedIn breach, the Yahoo breach, and the fish breach and everything, you know. And the thing about him is he gets all the breaches and then he verifies them. He has them to see if they're just lying. He puts a lot of work into making sure this list is accurate and good, and it's huge. He has a huge number of them in here. So it's that's the modern hotness. That's not in the book, but it is the new service to handle this problem.
And what was that?
Have I been pwned?
Oh, okay.
Yeah,
So
yeah.
you can even put your password
Yeah, your password or your email, and there's an API, so you can build it into software to automatically check this list. And that's what you should do. You should not let users use any password that's on that list. And that would be a lot better. Anyway, so that's a dictionary attack. So brute force attack is where you just try all possible combinations of characters. This almost nobody does this because even around 7 or 8 characters, this becomes untenable. But what they do is dictionary attacks, where they have a list of possible passwords. Rainbow tables are a time memory trade-off we talked about before, which are not that effective with modern systems, but they were very effective in the days of Microsoft's LM hashes. Another technique people use is take a word and then modify it by adding a number in the word or changing letters to numbers. So anyway, assault is a number you add to a password before hashing it. This is how you avoid just having online dictionaries like Microsoft's password hashes, because everybody uses the same password has exactly the same hash. This is a terrible idea. So you should add assault to it. So before you hash the password, you add a few random letters. Then you store the random letters next to the password. Now, if somebody else uses the same password, they have different random letters, so the hash is different. And there's no way to tell from the table that they have the same password. And now I can't make a master list of all the password hashes and look it up, because I have to have a password list for every possible assault value. And typically you have 8 random letters for assault, so there's a very large number of possible assaults. So this is what secure systems like Linux and the Mac use. Microsoft doesn't use it at all, but they should. So Microsoft instead has this stuff, the famous Microsoft password rules. You can have password age, history, complexity, and so on, which forces you to change your password after so much time and make your password so many characters long and have uppercase, lowercase, symbols, and numbers. And this is notoriously ineffective, but this is what Microsoft gives you. Even Microsoft has now admitted, and so has the National Institute of Standards this came from, that making you change your password every periodic is completely a waste of time. I never understood that. If you have to change your password every 30 days, this means it's okay for a crook to use a stolen password for 30 days. Exactly what did you accomplish with this? It's hard to understand what benefit you get from changing your password every 30 days. What is the threat model? You apparently think someone stole the password, and the fact that after 30 days it changes is going to stop something. In retrospect, they've decided this never did make any sense, and they never should have said that. Anyway, so that's the point. People write passwords and stick them stupid places, of course, especially if you make them change it every 30 days and you make them complex. Now they can't remember them, so they'll leave sticky notes all over the place. So just like Microsoft user account control in Vista, you made a stupid security rule that is so annoying that you end up less secure as people do stupid things to cope with your stupid rule. Every kid, I think, knows this when you go to school and the teachers and the principals and everybody have stupid rules and you get frustrated and evade their stupid rules. So to have something you can have a synchronous dynamic token that synchronizes with a server like the RSA Secure ID, or an asynchronous token where you press the button to get the next number. So you got a username, it sends you a challenge, you enter the challenge and in your token and then set it up. That's another way. I think the RSA Secure ID is much more popular, where it just updates every 30 seconds or something. So you can enroll something with a biometric system. You have to put in your finger many times, your Voiceprint reads something several times, so it memorizes something about you, and then hopefully can recognize you. Biometrics are pretty damn annoying. I haven't had much luck with them. But Face ID is pretty nice. But since it works so nicely for me, I bet it would be pretty easy to fool it. The fingerprint ID I find to be totally useless. Doesn't work at all for me. Other people like it. Anyway, this is an issue. The issue is how accurate is it? What's the false accept rate? What's the false reject rate? And how hard is it to enroll? So here's, all biometric systems have these parameters. There's a false accept rate and a false reject rate, and there's sensitivity. If it's insensitive, then it's easy to get through, and so it does not falsely reject authenticated users. So this is more convenient, but it means that the wrong person can fool it. If you make it more sensitive, then you have a lower chance of false exception, but a higher chance of false rejection. So your authenticated users are bounced at the door, which is what happened to me with the fingerprint reader here. I can't open it with my real fingerprint, almost never. So it's way over on the right, where it is too damn secure. I guess that means Cook couldn't use it either, but I can't use it, so it's not doing you much good. So you rate the quality of a sensor by the crossover error rate. This number, if it's lower, you have a better sensor. If it's higher, you have a worse sensor. And this adjustment is your security level. Do you value convenience or security? Or to be fair, do you value convenience or authenticity? Security is the judgment call of what is security for you. Like in this room, it's a public lab. Our public labs, I have no password, or I just have the same password on the board. There's no, because what I value is availability. That's security to me. I want it available. I don't want any barrier. Physical presence in the room is authentication enough. So that's security. Your security is the mixture of confidentiality, integrity, and availability that suits your business case and your threat model. And in a public lab like this with a human monitor, all I care about is that they're available to students that come in the room, not that they have to prove anything once they're in the room. But, you know, you have to consider what you're doing to decide what balance of the three is right for you. So fingerprints are the most common biometric control, and they make some kind of mathematical representation of features it finds like this on your fingerprint. Retina Scan is considered far more accurate, but it is not popular. People don't like sticking their eye in a cup, but that's what you have to do. Iris Scan is considered easier. You take a photograph of your face, and they've gotten, with modern things like the iPhone, they can do this from like up in the sky. So this is expected to really, facial recognition and iris recognition can now be done from a camera you walk past. So everyone's expecting this to be the next hotness. Like I say, I would think that contact lenses could prevent this. You certainly could make contact lenses with opaque parts. I would think they would help. And I would think that would be the way to get past this. Yeah. Then there's hand geometry. I tried one of these years ago. You put your hand in some kind of frame above a red light, and it measures something about the blood vessels in your hand. That's another one. It's not very popular, but they do make them. I've tried them. I've seen them go. Keyboard dynamics is where it measures something about your typing that is hopefully characteristic. What's that?
Actually, now that keyboards of how you press and it makes noise, the gamers like to know if they're touching the keyboard and it makes noise.
Oh, yeah.
And this is a new thing.
Oh, okay. Yeah, that's feedback. Like I remember when they had keyboards that buttons on calculators that click are better than ones that don't. You know you've done it. Feedback is useful. Okay. Anyway, there's a process of signing with a pen where it tracks your hand is another possible biometric. Voice prints are not much use. It turns out that everyone thought they were cool in science fiction, but it turned out to be very hard to make things that can understand voice, and human's voice changes a lot when you get a cold and stuff. Turns out to be much less useful than you think it would be, which is another example of the problem with computers, because humans can identify voices very well. So it's possible to really identify someone for a voice, but we haven't figured out how to teach our computers to do it yet. All right. Facial scan, facial recognition is the new hotness. This is going really far. Like I say, it's in my phone. It's everywhere. The Department of Homeland Security is really pushing it. Airports are switched to it already. This seems to be the winner in the biometric scheme, because you can do it without anybody's permission from a distance with a camera, and they're doing it all around us, whether you like it or not. And the cops already have databases of your DMV photo and all these other photos. So clearly this would be the coolest way for law enforcement. They already have photos of everybody anyway. And Facebook has jumped in by encouraging you to tag the people in the background of photos, so they have a bunch of more photos than you think they have of you. And so now the people got upset about this about a year ago. They found out that if you see like a girl on the street and you want to stalk her, you can take a picture and do an image search and find her real name and real address and Facebook and everything just from the picture. So there are serious privacy consequences, but that ship has sailed. The data is out there and there's no getting it back. So, you know, this is the brave new world. Remember, Google's big mission statement is to index all the world's information. Their fundamental purpose is the opposite of privacy. They want to make it easy to find out everything about everything. And they're doing a very good job of it, for better or worse. Something about your physical location is often helpful. You can locate yourself to some extent by IP address. If you have a phone with a GPS sensor, you've got that also. And so this is quite useful. Credit card companies can use this. If you scan a credit card, they can take the IP address of this credit card scanner and then the GPS of your phone and find out, are you really in that location buying it, or is this somebody from China sending a transaction? That's a pretty good idea, actually. I like that one. Anyway, all right. So this is probably 6A is what it's going to look like on here. Yep. All right. So what would you add to a password to make two-factor authentication? It has to be something different than something you know. It can't be some other thing you know. That's not two-factor. That's two of the same factor. It has to be something uncorrelated with it, like your IP address. That's what banks use. They say, notice my computer, and if I move and log into my bank, it says, you're logging in for a different location now. Is it okay or not? They remember if you're using the trusted computer with a cookie or an IP address, and that's the second factor, and that is not related to my password. See, if you have something like your hometown, you have to type in your hometown, they're just going to store that in a database too. Both of them will get stolen together. So it doesn't make you any safer. The only thing that makes you safer is two unrelated things, like something you know and something you have, or something you know and something you are.
And do when you go to a gas station,
yeah,
the zip code.
That they ask you for your zip code because you used your credit card. That's something you have, and your zip code is something you know. So that is two-factor, in fact, because they used your card. So your password plus your credit card number would be two-factor, but your password plus your hometown is not. But it's just another thing you know. All right. Yeah, the zip code too, yeah. All right, so which file contains the password hashes on Unix? The shadow file, strangely enough, not on Android. Android has some new system I don't really understand, but it's not in the shadow file anymore. Anyway, what stops online brute force attacks? Lockout. Account lockout, good. What's the weakest password hash? LM hashes are the famous ones Microsoft used that got cracked like crazy by the old loft crack and everything else. They upgraded to the NTLM, which is the vintage 1993 new technology hotness. Before that, it was even worse. This is still appalling. Linux is much, much, much better. Literally a million times better. Anyway, which biometric system lets unauthorized people through? That's a high false accept rate. False accept means you let the wrong person through. All right. So, Robert, PC, and T. Robert, PC, and T. All right. Fair enough. So it's 2:16, and we go till 4. Perhaps we should take a break. Take a break till 2:30, and then we'll pick up again. I'll stop this and break the video.